Alright, so what we're doing, we're considering the following pair of simultaneous equations. We have x squared plus 2xy equals 5 and x plus y equals 3. Alright, so we have two equations, as you can clearly see. And what's the difference between them? Well, in the first equation, we're seeing that x is a power of 2. In the second one, x is a power of 1. Y in the second one has a power of 1 as well. So this is what we call a linear equation. And this one will be considered to be a quadratic because we have a quadratic term. The power on the x is a 2. This is also considered to be in the second degree as well, not just the x squared being in the second degree, but this is also in the second degree because these two variables x and y are multiplying. So we will consider adding their powers to determine the type of term we have here. X has a power of 1, y has a power of 1, but since they are multiplying as in x times y, we will add the powers, giving us 2. So this is also in the second degree, not just this one. So this is really an equation in second degree, an equation in the first degree. Okay, so if we were asked to solve these two equations to find the values of x and y, we will not use the elimination method of subtracting both equations or adding both equations, but instead we use the substitution method. Now here's the thing. In the first part of the question, we're asked to show that the point or ordered pair with x being 1 and y being 2 is a solution for the pair of simultaneous equations. Now how do we do that? It says without solving. We need to show that this ordered pair here is a solution. So in order for us to do that, what we do, we will take x equals to 1. That's the first coordinate. That's the x coordinate. And the second coordinate is the y coordinate. So y is 2. And we're going to enter or substitute x and y with those values 1 and 2 respectively. So let's take the first equation and see if those two values satisfy the first equation. So to determine whether those two values satisfy the first equation, what we need to do is to do what? Substitute. Alright, so wherever we have x, we're going to put what? 1. Write back everything else. Wherever we have y, we're going to put 2. Write back everything else. That gives us 1. 2 ones 2 plus 2 ones 2 times 2 give us 4. Since you're multiplying everything here, it's saying 2 times the value of x times the value of y. So 2 times 1 times 2 give us 4. Alright, this is not the distributive law. Okay, 1 plus 4, that's 5. So we have 5 is equal to 5. So the order pair 1, 2 satisfies this equation that we have here. This first equation, this equation 1. Will it satisfy the second equation? Let's check. That's the second equation we're given. So we're going to replace x with 1 and y with 2. And that's an obvious solution there, right? So we have 1 plus 2 is 3. So yes, we can clearly see that the ordered pair with coordinates x equal 1 and y equals 2 is a solution to the pair of simultaneous equations. Alright, so the next part of the question asks us to solve the pair of simultaneous equations above to determine the other solution. So there's another solution, not just the 1, 2, but there's another solution. So let us do that one. Okay, let's just do that one right now. So for us to solve this pair of equations, we recognize that we cannot add or subtract both equations because one is in the second degree, one is in the first degree as explained earlier. But instead what we'll do, we'll take the linear equation, which is x plus y equals 3. That's equation 2. And what we'll do, we'll make either the x or y the subject. Now let's make y the subject. Alright, since we've seen we have an x squared term here, so I will leave this, it would not trouble this one. It's pretty easier to replace the y. So I want to replace this y. So I'm going to make y the subject. You'll understand a little better. So let's get y as a subject. So we have y equals 3. Now, what happened to the x? So an equation has two sides. We have the left hand side equal the right hand side. I want to eliminate the x here. So if I eliminate x, I'll have positive y on this side equal the positive 3 on this side. But what happened to the x? To get rid of this x, I need to subtract it. Because another way of saying this is saying positive y plus x. Because this x is positive. So it's saying y plus x. So to get rid of this plus x, I need to subtract x. Our positive x, we need to subtract x. If I subtract x from this side, which leaves me with y on this side, I need to also subtract x on this side. So it seems as if I transpose this x to the other side of the equation, but once you move from one side of the equation to the other side, the operation in front will change. So from a plus x to a minus x. Okay, so now we have y is 3 minus x. Alright, so we're going to use this instead. Alright, let's consider this to be equation 3. But we're not going to just use this as an equation. What we're going to do, we're going to replace the y with 3 minus x. Later on, we'll use it as an equation, and you'll see. Okay, so I'm going to write back this equation, which is equation 1. We haven't used it as yet in solving, so let's write back equation 1, which is x squared plus 2xy is equal to 5. That's equation 1. That's the original equation we're given. And what I'm going to do, wherever I see y in this original equation, the second degree equation, I'm going to put 3 minus x. Wherever I see y, because y is what? 3 minus x. So wherever I see y, which is just here, I'm going to replace it with 3 minus x. That's what we call a substitution method. We're substituting y with 3 minus x. So I'm going to have x squared plus 2 times x times the expression for y. And we use brackets so we can multiply the entire expression of 3 minus x. So collectively, this is y equals to 5. Alright, next. I'm going to say x squared, write back x squared. Now I'm going to distribute by way of multiplication. This is a distributive property, a distributive law. Whatever is immediately out the bracket by the terms in the bracket. So this is a positive 2x times 3, which gives us positive 6x. Positive 2x, again, will multiply the negative x. Even though we're saying minus x, we're treating it as negative x. So when I say 3 minus x, when I not think of the 3, I read it as a negative x. So 3 minus x, ignoring the 3, we treat it as negative x. So we're ignoring the 3 now because we're multiplying by the 2x. Because I'm ignoring x squared, I'm seeing this as a positive. So it's positive 2x times negative x. Now, positive times negative will give us negative. And 2x times x give us 2x squared. I'll write back what I'm not using, which is equal 5. Okay, now let us simplify this side. So we're going to collect the x squared term. So here's we have another one. So these are like terms because they can be simplified by addition or subtraction. Okay, so x squared minus 2x, x squared minus 2x. Now if you're asking why the sign didn't change, it's because we're still on the same side of the equation. This is the left hand side equal the right hand side. Since I move the minus 2x squared, which is on the left hand side, and put it next to the x squared, which is still on the left hand side of the equation, the sign will remain the same. Only if you're moving from one side to the other does the sign in front will change. So for instance, this positive 6x here, I'll still keep it on the left hand side. It's just that I'll put it after the minus 2x squared, but I'll still have to keep or maintain this positive 6, the positive sign. So it's still positive 6x. Okay, next, I want to ensure that when I have a quadratic equation, that it's equal to 0. you must have it equal to 0 in order to solve it. So this 5 on this side is the easiest one to move rather than moving all 3. So I'm going to need to do what? I'm going to need to remove this 5 from this side. So let's do that. So I'm going to say x squared. Now mind you, before I put x squared here, let's simplify this, because these are like terms. This is saying 1 x squared minus 2x squared. Now since there's a 1 that's in front of the x squared, but we usually don't write 1, 1 minus 2 is negative 1. Not 2 minus 1, but 1 minus 2. That will give us a negative 1. I'll write a negative in front, but we don't put the 1. Just like we don't have a 1 here, we do not put the negative 1 here. We just put a negative. So it's negative x squared. This has been simplified to negative x squared. I'm going to write back the positive 6x. Now this 5 here, we will need to remove it from this side. So we're going to subtract it. Okay? Because it's positive 5, we want to subtract to get rid of it. By subtracting 5 from this side, it's like saying 5 minus 5 give us 0. But because I subtract 5 from this side, I need to subtract 5 from this side as well. So it seems as if the 5 would have transposed over to the other side in the next step. From here, transposed, leaving 0 on this side, and the sign in front of it, which is positive, becomes a negative. But really, in fact, it's that we subtract 5 from this side, we need to subtract it from this side as well. Okay, hope that point is taken. Next, I do not want the negative in front of x squared. So this is x squared, this is a 2 by the way, negative x squared. No, I do not want this negative in front of it. Since it's an equation, in other words equal quantity, I am able now to change the signs. I don't want an x squared, the minus x squared, I want a positive x squared. So I'm going to multiply the entire equation here, this equation. I'm going to multiply this equation by negative 1. That allows me to just change the sign, because negative 1 when multiplied by negative x squared give us a positive x squared. This negative 1 times 6x will give us a negative 6x, and this negative 1 times negative 5 give us a positive 5, and this negative 1 times 0 will give us 0. So every term in the equation gets multiplied by negative 1, even the 0. Alright, so this allowed us to have a positive x squared, which is much easier to factorize. Okay, now we can factorize this. Now in case we aren't able to factorize, we can use the quadratic formula, which looks like this. Should be on the formula sheet. Negative b plus or minus the square root of b squared minus 4ac all over 2a. But we wouldn't have no need for this, because we can clearly see that this will become what times what will give us x squared, x times x. And what times what will give us 5? Well, 5 is a prime number, so only 1 times 5 will give us 5. But we have other factors of 5 besides 1 and 5. Let's see. We know that 1 times 5 will give us 5. But did you know that negative 1 multiplied by negative 5 also give you 5? Because negative times negative is positive. 1 times 5 is 5. So we want to ensure that we'll get the middle term of negative 6x. So instead of using 1 and 5, we'll use negative 1 and negative 5, because when we add them, that will give us a negative 6. So we use a negative 1, negative 5. Now you can look at factorization, check out other videos on YouTube, and you should be able to see how to factorize quadratic expressions. Alright, but that skill is needed for us to simplify or factorize expressions and continue to solve. Alright, so if this quantity times this quantity give us 0, it means that either this quantity is 0 or this one is 0. If we multiply two numbers, let's say p times q, and you get 0, it means either p is 0 or q is equal to 0. if this is p0, 0 times whatever q is, give us 0. If q is 0, 0 times whatever p is will give us 0. So it's on that backdrop that we're saying that, okay, if x minus 1 work out to be 0, then whatever this works out to, it wouldn't matter, we'll still get 0, because when we multiply this by this, we get 0. And that's what the two brackets, pair brackets, are saying there, right? This quantity times this quantity, the result of both. So let's write it. Either x minus 1 equals 0 or x minus 5 equals 0. And if that's the case, now that we have two linear equations, I mean the highest power is 1, so it means that we can just isolate x to solve for x. So what minus 1 gives us 0? 1. So x must be equal to 1. Or what minus 5 gives us 0? 5. So x must be equal to 5. Now here's the thing. If we say that we have a minus 1, if we add a 1 to this side, we'll cancel out 1. So we have to add 1 to this side as well. And adding 1 to 0 give us 1. So we have x equal 1. If we add 5 to minus 5, we'll cancel them out. And we add 5 to this side as well, we get 5. So we have x isolated by adding 5 to this side. X equal, adding 5 give us 5. So that's another way to look at it. So we have the two values for x. But remember, for the original equations, we were asked to do what? It says here, without solving, show that the ordered pair 1, 2 is a solution. Meaning when x is 1, y is 2 for both of these equations. So check it out. When x is 1, we know what the answer is going to be 2. Because that was given to us to check. And we found out when x is 1, y is indeed 2. So it's the other solution that they want us to find. Hear what they said here? They said here that we should do what? Solve the pair of simultaneous equations above to determine the other. Not the others, but the other. Well, the other solution. Not solutions. Okay, so we already have what? We already have x equal 1. And we know that the y value, when x is 1, y is going to be 2. But let's double check though. Remember we said that we're going to use, instead of using this linear equation, we will use this one in the future. Because that's why I write it as an equation 3. But they're basically the same equations. It's just that y is already the subject. So we have y equals 3 minus x, which is just this. So I'm going to use this one since it's easy to substitute x, the value of x here, and 3 minus whatever x is. 3 minus whatever x is will give us what the value of y. So for instance, remember we found the x value to be 1. When you put 1 here, what happens? Y is equal to 3 minus 1, and 3 minus 1 is what? 2. I mean, we could have done it here too, you know. We could have said, okay, x is 1, so 1 plus y equals 3. 1 plus 2 equals 3, so y is 2. Okay, so we already have that solution. So it's the other solution that we're looking for when x is 5. So let's use the same equation that we have, y equal 3 minus x, which comes from x plus y equal 3. That's equation 3. And it's when we're saying here when x is equal to 5, y that we have here we're saying that y is equal to 3 minus the value of x being 5, and so y is equal to negative 2. So the other solution is really when x is 5, y is negative 2. And this is the other solution. Alright? I mean, if you wanted to check with when x is 1, I mean, you don't have to do that because we already know it's going to be that, but using the same equation, y equals 3 minus x, right? When x is 1, y is equal to 3 minus 1. We can see that y is equal to 2. But this was already given to us. The solution here had already given to us that when x is 1, y is 2. And we checked this already as the first part of the question. So this is our other solution.